Hi, in this tutorial we are going to solve a question related to nucleophilic addition and substitution reactions of carbonyl compounds. The question asks, predict the products for the following nucleophilic addition and substitution reactions. Let's analyze each option one by one. So, in the first one, let's look at, we have here an aldehyde, and here we have a carboanion, and then here we have hydronium ion. So basically we can predict the reaction here since we have an aldehyde, and we know that aldehydes and ketones, they undergo nucleophilic addition reactions. Our nucleophile here, this methyl anion, methyl carboanion. So basically what's going to be the reaction? The reaction will be addition of this anion, this nucleophile, to carbonyl carbon. We know that the carbonyl carbon is an electrophile because of the electronegative oxygen atom here. So there is going to be an addition reaction. Let's just write the mechanism, then let's guess what's going to happen. This carbonyl will be attacked by this carboanion, and let's just draw the product. So we will have here a tetrahedral intermediate, because the pi electrons will flow as a lone pair on oxygen. Then this will happen. So this will be a negatively charged oxygen. There will be a hydrogen here, and we have CH3, and then since we have here a hydronium ion, hydronium is going to protonate this oxygen, negatively charged oxygen. Let's write the mechanism for this step also. So the protonation will result in an alcohol. So basically this is an addition reaction, and it generated, I'm going to shift methyl group upside so that you can see that. So this was an aldehyde, and aldehyde produced a secondary alcohol. Let's move to the second question. Second question is a similar question. We have here a ketone, and we have here a nucleophile, a hydride anion. Again, we have here a hydronium ion, which will protonate again the tetrahedral intermediate expected to be produced in this reaction. So let's just again write the reaction mechanism. Hydride ion will attack carbonyl carbon, and we will form a tetrahedral intermediate. Here this will be negatively charged oxygen. I'm going to write hydrogen, or I'm going to draw here the hydrogen bond here, and then in the second step, this was the first step, generation of the tetrahedral intermediate, we will have here hydronium ion. Hydronium ion is going to protonate this tetrahedral intermediate. Let me just draw with the red arrow to be consistent with the previous question. Then we are forming here again an alcohol. Here OH. I'm just drawing hydrogen again. So again we produced here a secondary alcohol. Let's move to the third option. Third option is a similar question. Here we have an aldehyde. This is benzaldehyde. Sometimes aldehydes can be written as CHO. So I'm going to draw the benzaldehyde as this way, so that we can write the reaction mechanism similar to the previous questions. It will be C, carbonyl oxygen, carbonyl carbon, and hydrogen, and the nucleophile here is cyanide anion. So we expect the same reaction. Cyanide will act as a nucleophile. It will be added to carbonyl carbon. Again, let's do it with a red arrow for the reaction mechanism. Lone pair on carbon will flow to the carbonyl carbon, and we will form here a tetrahedral intermediate. And tetrahedral intermediate will be protonated by the hydronium ion. I'm not going to draw the second step, and we are going to form here this molecule as the product. So aldehyde will be converted to alcohol. This will be the carbon-nitrogen triple bond. So again, we formed a secondary alcohol here. Let's move to the fourth option. The fourth option, we have here a carboxylic acid derivative. This is an acid chloride or acid halide, and we know that chloride is a leaving group, so in this reaction we expect a substitution reaction, nucleophilic acyl substitution reaction. Here methanol is going to substitute the Cl on the acid chloride. So let's just write the reaction mechanism. So oxygen will act as a nucleophile, and then we will form a tetrahedral intermediate. We can show in the same step tetrahedral intermediate will collapse to an sp2 hybridized structure, then chlorine will leave. So basically, instead of drawing two steps, we are drawing the reaction mechanism in one step, and we are going to show the product here as this. So let's draw a little bit better. So instead of an acid chloride, we form an ester plus HCl. And in the last example, again we have an acid chloride and we have an amine. We know that amines are acid basic and they are nucleophilic. So again here we expect a nucleophilic acyl substitution reaction. Chlorine will be substituted by this amine, methylamine, and the corresponding product will be here an amide with NHCH3, and plus we will lose chlorine and we will form HCl. So basically in this question we solved 5 sets of reactions, and the first 3 were aldehyde ketone reactions with nucleophiles. They were addition reactions, and additions form tetrahedral intermediates. Then tetrahedral intermediates will be protonated with acids, hydronium ions. And in the last 2 examples we had nucleophilic acyl substitution reactions. We had acid halides. Chlorines are good leaving group, so the nucleophile methyl alcohol and methylamine reacted. Then we formed in the first case an ester, in the second case an amide. Thank you so much for watching.